All right, we're going to continue with rational exponents, and we're going to talk about some older rules that we actually have already learned. Our first rule is often called the product rule. It's where we have a base, a in this case, raised to a power, times a base, the same base, raised to a different power. And what we end up doing is adding the exponents, a to the m plus n power. Our next rule is often called the power rule. It's where we have a base raised to a power, raised to another power, in this case, to the n power, and we end up multiplying the exponents. So we end up with a raised to the m times n power. Now we're going to do some variations on this. When we have two bases raised to a power, like a times b, raised to the n power, we give an exponent to each base. Please note this only applies when we are multiplying, or in just a minute, when we're dividing. Next up, we're going to have two bases that are divided raised to the same power, a over b in this case. And this breaks up into a to the n over b to the n. Again, please note this only applies by giving the exponent to everybody when we are multiplying or dividing. If I'm adding or subtracting the bases, this rule does not apply. The next rule is if I'm dividing the same base. I have a to the m divided by a to the n. I end up subtracting the exponents. So same base, but the exponents get subtracted. Our next rule is if we raise a base to the 0 power, that's always going to equal 1. We have one minor exception to this. The base, a in this case, cannot be 0. But any other number for a raised to the 0 power is always equal to 1. Our last rule is often called the reciprocal rule. If I have a raised to a negative exponent, that's the same thing as rewriting it as 1 over a to the positive n power. Everything switches. Let's start with this first example. We're going to start with y raised to the 2/3 power times y raised to the 8/3 power. Now if we use rule number 1 up above, I have the same base multiplied. I'm going to keep the same base, y in this case, and I'm going to end up with 2/3 plus 8/3 in the numerator, or in the exponent, pardon me. Very nicely, we already have the same denominator. If we didn't, we'd have to get it. And adding the 2 and the 8, we get 10 over 3 as the exponent. The base remains the same. Next up, and you'll need to ask your teacher read the directions. Do you want to keep it in exponential form? So this previous example, we have y to the 10/3. Possibly we would need to rewrite it as the third root of y to the 10th power. Again, you would need to know if you needed to write your answer in the exponential form or in the radical form. This next example, we're going to have a fraction. We're going to have 9 raised to the 2/7 power over 9 raised to the 9/7 power. And using our rule number 2 up above, number 5 up above, we're going to keep the same base, 9, and the exponent is going to be 2/7 minus 9/7, which will simplify down to, again, nicely, we have common denominators. 2 minus 9 is negative 7 over 7, which gives me 9 raised to the negative first power. Now, using the last rule up above, rule number 7, when I have a negative exponent, that says I'm going to bring it down to the denominator. So this becomes a positive 1 over positive 9. And that's my final answer for that one. This next one, we're going to apply the power rule, which is going to be rule number 2 up above. I have 11 raised to the 2/9 power, all raised to the 3rd power. Now the rule up above says I'm going to multiply the exponents. The base stays the same, 11, raised to the 2/9 times 3, giving me 11 raised to the 6/9 power, which reduces to 11 raised to the 2/3 power. And just to show you what it looks like, we're going to rewrite this in radical form. So this is going to be the third root of 11 to the 2nd power. You can rewrite 11 to the 2nd power as 121 under the radical, but this is okay for now. Next example. We're going to have in the numerator, parentheses, 3 raised to the negative, times x, raised to the negative 2/3 power, all raised to the 3rd power, over x to the 2nd power. Notice that 3rd power up above only applies to what's in the parentheses, not the denominator in this case. Using the rules above, I'm going to get 3 raised to the 3rd power, times, and I'm going to use parentheses here, x to the negative 2/3 power, raised to the 3rd power, and the denominator stays the same as x squared. Three raised to the 3rd power, remember, is 3 times 3 times 3. That gives me 27. Applying the rule above, I have a power raised to a power. That's going to give me x to the negative 2/3 power. And I'm going to notice that the 3's reduce out. Down below, it's still x squared. It remains the same. Using my rule up above, I get 27. And I'm going to get x to the negative 2nd power goes down to the denominator. I'm going to have my x squared from before times another x squared because the base from above moved down. And now I have a base times a base in the bottom. I have 27 over, and applying rule number 1, I get x to the 4th power. Now that may seem a little weird because I'm dividing, but in the denominator I'm actually multiplying. So rule number 1 applies here. My final answer is the 27 over x to the 4th power. My next example is going to be even more complicated. You can do this, hang in there. I'm going to have 3 x to the 1/4 power, y to the negative 2/3 power, all raised to the 4th power. And that's just the numerator. The denominator is going to have x to the 4th power times y. Now up top in the numerator, that exponent is going to apply to all 3 bases. The 3 is going to be raised to the 4th power. X to the 4th also gets a 4th power. And the y to the negative 2/3 also gets a 4th power. All the bases get a 4th power. Down below it stays exactly the same. Next up, 3 to the 4th power actually becomes 81. The x to the 1/4 raised to the 4th, the 4 is reduced because I'm multiplying the exponents, and I just get x, or x to the 1st. The y, I have to multiply. Remember, the 4th power on the y is over 1, so I get negative 8 over 3. This is all over x to the 4th y. Now I'm going to subtract, so I'm going to get equals 81 x to the 1 minus 4 power times y to the negative 8/3 minus 1. And now I need to subtract here, so I get 81 x to the negative 3rd power y to the negative 11 over 3 power. Remember, you're going to get a common denominator. You can work that out on your own. Now, all the negative exponents there, they all drop to the denominator. So I have an 81 up top. Down below, I have x to the 3rd. And I have y to the 11/3 power. We could rewrite that in radical form again like we did above, but we'll just leave it in exponential form in this case. All right, let's change directions here just a little bit. This next example, we're going to start out in radical form. I'm going to have the fourth root of x raised to the third power, parenthesis, the fourth root of x minus x to the third power. Now I have everything written in radical form in this case, and if it's written in radical form and it's easier to rewrite it into exponential form, we're going to do that. So I'm going to rewrite this as x raised to the 3/4 power times x raised to the 1/4 power minus x to the third power. Now it's a little bit easier for me to kind of see what I'm going to do with my exponential rules. I'm now going to distribute the x to the 3/4 power. So I end up with x to the 3/4 times x to the 1/4 minus x to the 3/4 times x to the third. Now I'm going to apply rule number 1 from before, and I'm going to add the exponents, keeping the base the same. I'm going to get x raised to the 3/4 plus 1/4 power minus x to the 3/4 plus 3. Now this first one, very nicely, we have a common denominator. I end up with x raised to the 4/4 power. This next one, not so much. I'm going to have to get a common denominator of 4 in this case, which is going to give me 12 plus 3 is going to give me 15 over 4 power. So however you need to get your common denominator is fine. So I'm going to go ahead and simplify this up a little bit, and I get x all by itself, it's just to the first power, 4 over 4 is 1, minus x to the 15 over 4th power. Now I'm going to leave it in exponential form, but you'll need to read the directions on your homework or on your test to find out if you need to write it in radical form or not. This next example, we're going to start out in exponential form. So I have x to the 1/4 power minus 1, plus 1, pardon me, times x raised to the 1/4 power minus 7. Here I'm going to have to FOIL. So I'm going to multiply x to the 4th times x to the 4th minus 7 times x to the 4th plus x to the 1/4 power minus 7. Now the first part, this x to the 4th times x to the 4th, I have to apply the first rule, and I'm going to add the exponents, which gives me x to the 1/4 plus 1/4 power minus 7 to the 1/4. Pardon me, we have like terms. Negative 7 to the 1/4 plus x to the 1/4. We're going to get minus 6 to the times x to the 1/4 power minus 7. Now, nicely, I have common denominators. I get x to the 2/4 power minus 6x to the 1/4 minus 7. And I'm going to reduce the exponent in this case to get x to the 1/2 minus 6x to the 1/4 minus 7. And just because the directions may be different, maybe the teacher doesn't want it in exponential form, we're going to rewrite this in radical form. So this is going to be the square root of x. Remember, we don't write the 2 because it's the second root. Minus 6 times the 4th root of x minus 7. Again, you need to read your directions. The previous example, we wrote it in exponential form. This last example, we wrote it in radical form. All right, so let's start using these new forms to simplify some radicals. So we're going to start with the 9th root of x raised to the 3rd power. And rewriting this in exponential form, I get x raised to the 3 over 9th power, which very nicely reduces to x raised to the 1/2 power, the 3rd power. And Depending how your teacher wants it, they may want to keep it in exponential form or rewrite it as the cube root of x. Just a couple more examples here. This next one, we're going to have the fourth root of r raised to the second power times s raised to the sixth power. Rewriting this, I'm going to get r to the second power, s to the sixth power, in parentheses, all raised to the 1/4 power. And now I'm going to use my exponential rule and give a 1/4 power delivery. So I get 2 times 1/4 times s to the sixth raised to the 1/4. Multiplying them out, the exponents, I get r raised to the 2/4 power, s raised to the 6/4 power, and now I need to simply reduce the radical. R to the 1/2 times s raised to the 3/2. And you'll notice I can kind of work backwards with the exponential rule and end up with, it's sort of like I'm factoring out a 1/2 if need be. I'm going to get r raised to the first power, s raised to the third power, all raised to the 1/2 power. Notice if you use the exponential rule and bring that 1/2 back into the parentheses there, you get the previous example. And if I need to write this in radical form, I can simply rewrite it as radical r s to the third power. Your teacher may want you to leave it in exponential form or in radical form, so we have both here. All right, almost done. Last example. We're going to end up with cube root of y over the fifth root of y. Rewriting these bases with their exponential fractions, I get y to the 1/3 over y to the 1/5. According to my previous rules, rule number 5, if you look back, I'm going to have to subtract the exponents. So I end up with y to the 1/3 minus 1/5. I have to get a common denominator, in this case of 15. And when I subtract, I get y to the 2 over 15th power. You'll need to double check your fraction work. Maybe scratch paper off to the side if need be. Rewriting it in radical form, I get the 15th root of y raised to the second power. And there you have it.